Welcome. This video is CCBYNC. Welcome back, everyone. This is the third part in a five-part series of graphing trigonometric functions, and today's lesson is on phase shift. This is also sometimes called a horizontal shift. And before we get going on exactly what a phase shift does to a graph, I'd like to put on the original graph, the y equals sine x. And if you recall, we start at 0. We'll go up to 1 at pi over 2, down to 0 at pi, -1 at 3 pi over 2, and back up to 2 pi. So here is our original trig function, y equals sine of x. And what we want to know is what happens when we subtract pi over 2 from the domain. Well, what that means is when I plug in pi over 2 here, pi over 2 minus pi over 2 is 0, and sine of 0 is 0. And I'm going to plot these points as we go. So at x equals pi over 2, y is going to be at 0. At pi minus pi over 2 is pi over 2, and sine of pi over 2 is 1. So this means at pi, I'm going to be up at 1. 3 pi over 2 minus pi over 2 is going to be 2 pi over 2, or just pi, and sine of pi is 0. That means I'm back down here. Then at 2 pi, it's over here. 2 pi minus pi over 2 is 3 pi over 2. We know that sine of 3 pi over 2 is -1. And we have to actually extend our graph. It's not big enough, and this is going to be an exaggeration. At 5 pi over 2, 5 pi over 2 minus pi over 2 is 4 pi over 2, or 2 pi, and sine of 2 pi is 0. That brings us back up here. And you can see we end up with a graph looking similar to our blue graph, but everything's shifted over by pi over 2. So everything is shifted to the right by pi over 2. Now, what can we conclude from this? Well, if we have a function y equals a sine of b times x minus c, or y equals a cosine of b times x minus c, then we can say that the amplitude is the absolute value of a. We can say that the period for sine or cosine is 2 pi divided by b. And now we can say that the phase shift is c. Notice it's the opposite sign. And if c is negative, then it shifts to the right. If c is positive, then it shifts it to the left. So in our example here, it was negative, so we went to the right that way. All right, let's do an example. Let's do a couple of examples. Find the period, amplitude, and phase shift of the function y equals 4 cosine x minus pi over 4. Let's start with the amplitude. Amplitude in this case is 4. Absolute value of 4 is 4. Period in this case, b in this case is a 1. So this is 2 pi over 1, or just 2 pi. The phase shift in this case, it's always the opposite sign. So in this case, it's pi over 4. Not too tough. Let's do it again with the function y equals negative cosine of 2 pi x plus 3 pi over 2. This is going to get slightly messy because what we have to do is rewrite it, the 2 pi x plus 3 pi over 2. We have to factor out that 2 pi so that it's in the proper form for either sine or cosine. So I'm going to factor out a 2 pi. We're going to have to clean that up. 3 pi over 2 multiplied by the reciprocal of that, 1 over 2 pi. You will note the pi's reduce out. And we end up with 3 over 4, which means our function can be rewritten like this. This way, we more clearly can see what A, B, and C are. Let's start with our amplitude. It's the absolute value of -1. Now, I explicitly wrote the -1 in there. Originally, I didn't have that, but I wanted to really emphasize that the amplitude in this case is just 1. The period in this case is 2 pi divided by 2 pi, which is just 1. And the phase shift is -3/4. Remember, it's always the opposite sign of what's there. All right. Let's graph a few of them with a phase shift. All right. Graph the function y equals 2 cosine 2x minus pi. Now, I want to rewrite this by factoring the 2 out. Here we have the amplitude is 2. Let's take care of the period. 2 pi divided by 2 is pi. So that's going to be the entire span of one wavelength. It's not 2 pi anymore, it's down to just pi. And what I'm going to need to do is come up with my critical values. And the way I'm going to do that is I'm going to take, if you remember, we take the period pi and we always divide it by 4. So pi over 4 is going to be for our critical values. And they're going to be spaced pi over 4 apart. So our first critical value, without the phase shift, we'll come back to the phase shift here in a second, is 0 pi over 4, add pi over 4 to that. That's 2 pi over 4, which I know reduces, but for simplicity, we're going to keep it unreduced. You'll see why in a second. Then 3 pi over 4, then 4 pi over 4, which is just pi, right? Which is my entire period. Now here's what the phase shift does. It says that what we need to do is the opposite. It says sub minus pi over 2, that means add pi over 2. So what we're going to do to each of these critical values is we're going to add pi over 2, which pi over 2 is 2 pi over 4. I'm doing that because I want to keep all the denominators 4s. it's going to make it a little bit easier. So if I add pi over 2, 0, that's going to give me pi over 2. There's my new critical value with the phase shift. The first one. Next up, pi over 2 plus pi over 4. Actually, I'm going to use the 2 pi over 4 plus pi over 4 is going to give me 3 pi over 4. Next up, 2 pi over 4 plus 2 pi over 4 is going to give me 4 pi over 4, which reduces to pi. Three pi over 4 plus 2 pi over 4, that's going to give me 5 pi over 4. And lastly, 2 pi over 4 plus 4 pi over 4 is 6 pi over 4. 6 pi over 4 reduces to 3 pi over 2. So these are my new critical values. So these are the ones with the phase shift that I'm going to actually graph with. All right, we're going to come back to our graph, and I want to mark down each of my new critical values. So the first one's going to be pi over 2. So this is pi, half of that's there. So here's my pi over 2. This is where I'm going to start. Next up, 3 pi over 4. That's actually right here. Remember, we've really compressed it as well as shifted it. Next up for my critical value is pi, which we have here. That is 5 pi over 4. That's here. And then 3 pi over 2, which is the next one over. So our entire cosine wave is going to fit there. Now remember, our amplitude is at 2. Remember, cosine starts up. So we're up here. Go down to here. Go down to -2. To 0. And back up to 2. Ooh, that is tight. There's our graph. You can see it's been compressed and it's been moved. Normally we would start over here, but because of the phase shift, all the x values are moved to the right because it's minus. All right, let's do another one. So this one's going to be a little messy as well. I need to first of all factor out the 2/3 from this here, so we can see what that's going to look like. I'm going to use my scratch paper again. So 2/3 x minus pi over 3 becomes 2/3 times x minus pi over 3 over 2/3. Now, this actually becomes pi over 3 times 3/2. Remember, when you divide by a fraction, you multiply by the reciprocal. So 2/3 x minus, and you can see the 3's reduce out. And we're at pi over 2. So I'm going to rewrite my function as 1/2, there's my amplitude, 1/2, sine of 2/3 and x minus pi over 2. That comes from here. Let's talk about the period. Two pi divided by 2/3, which is 2 pi times 3/2, which is pi over 3. Oh, 3 pi. 3 pi. The 2's reduce out, right? Then we get 3 pi. Okay, so it looks like our starting point is going to be pi over 2. Everything's been shifted over. And let's come up with our critical values. So critical values. Remember, we take the period, 3 pi divided by 4, and that's going to be our incremental sizes. So we're going to start at 0 for now. Add 3 pi over 4. Add another 3 pi over 4 to that. That's 6 pi over 4. 6 pi over 4 plus 3 pi over 4 is 9 pi over 4. Add 3 pi over 4 to 9 pi over 4. That's going to give us 12 pi over 4. 12 pi over 4 is 3 pi, which we know is our period. But now we have to deal with the phase shift. So to deal with the phase shift, what we're going to have to do is once again add, in this case, again, pi over 2. That is from right there. Happens to be the same as that one. It's not always pi over 2. It happens to be the same in this case. And as I add these pi over 2 to 0, I get pi over 2. Pi over 2 to this, I get 5 pi over 4. Add pi over 2 to this, and I get 8 pi over 4, which is 2 pi. Add pi over 2 to this, and I get 11 pi over 4. And add pi over 2 to this, and I end up with 14 pi over 4, which becomes 7 pi over 2. Here are my new critical values. Let's mark them up. First one was pi over 2. This is pi here. So midway here is pi over 2. Next up, 5 pi over 4. That is 1, 2, 3. Each of these are pi over 4. So this becomes 5 pi over 4. Next up is 2 pi. Next up is 11 pi over 4. 1, 2, 3. 11 pi over 4. And last up is 7 pi over 4. 1, 2, 3. 7 pi over 2. It's 14 pi over 4, which is 7 pi over 2. Whew. So all I've done is written up the purple. Right, this is a sine wave, so we're going to start down at 0. Let's see what this bad boy looks like. Our amplitude is only a half, so I'm not going all the way up to 1. So I'm going to start here at 0. I'm going to go up to 1/2, back down to 0, down to 1/2, and back to 0. So our graph looks like this. These take practice. There's no fast way to do these. Just takes a bit of hard work.